have go for main engine start.
Baby, go. There it goes. Right there. There it goes.
On a 3, 2, 1. We have ignition. We have ignition of the solid rocket boosters and liftoff. Liftoff of America's space shuttle, and the space shuttle has cleared the tower.
You do think that it... That's great.
Sometime in early October 1984, the first Canadian astronaut was to have been launched into orbit aboard the space shuttle. In this episode of Astronomy Toronto, we will look at the plans for this historic mission. We will talk to one of our astronauts, Steve Maclean, about what it is like to be an astronaut and the hectic schedule astronauts have. We'll spend some time with all of our astronauts as they go through their training and prepare for the flight. There are many experiments planned for this flight aboard the Space Shuttle Challenger. There will be tests to see why astronauts get sick in space. About 50% of them do. Investigations will be made into why the shuttle exhibits a mysterious glow in orbit. Tests will be made using the canadarm, and a satellite will be launched. And even the problem of why food tastes different in space will be looked at. Marc Garneau, our astronaut, will be launched with 6 American astronauts for a 1-week mission. They are scheduled to land at the long runway in Florida at the Kennedy Space Center. Back in July 1983, a call was made by the National Research Council in Ottawa for astronaut candidates. Within a few weeks, over 4,000 applications had been received, and by December, 6 successful astronauts were chosen. Let's meet them now. Ken Money, 48, is the oldest astronaut and currently lives in Toronto. Dr. Money has a strong background in space sickness research. Dr. Roberta Bondar, 37, is a neurobiologist at McMaster University in Hamilton. Steve Maclean, 28, is an Ottawa native with a PhD in astrophysics and laser physics from York University. Bjarni Tryggvason, 38, is a native of Iceland with a degree in engineering. Dr. Robert Thirsk, 30, is a medical doctor. He holds an MA in biomedical engineering from MIT and a medical degree from McGill. Finally, Marc Garneau, 34, is a commander in the Navy, an engineer and design specialist in communications and electronic warfare. Marc Garneau has been selected to take the first trip into space. His backup is Bob Thirsk. So if anything happens to Marc where he cannot make the flight, Bob Thirsk is already trained and ready to go up in his place. There are 3 types of space shuttle astronauts: the pilot, the mission specialist, and the payload specialist. The pilots are the ones that actually fly the orbiter. The mission specialists are astronauts who are expected to go up into orbit a few times on different missions. The third is the payload specialist. Marc Garneau is a payload specialist who is training to operate experiments for one certain flight. The experiments chosen for this mission fall into 3 main categories: space technology, which will deal with using the canadarm; space science, which will deal with the physical characteristics of the space environment and of the Earth's upper atmosphere; and life sciences, where we'll learn more about how man is affected by zero gravity. Toronto's canadarm has been one of the most successful aspects of the Space Shuttle program thus far. Built at Spar Aerospace, the shuttle first operated the canadarm in November 1981 on the 2nd mission. This was just a simple test of the first canadarm in orbit. On the 3rd Space Shuttle mission, the canadarm was used to pick up several experiments which were moved around the orbiter and then put back into the payload bay. On the 7th mission, the Canadarm picked up a satellite, released it, and then retrieved it again and put it in the payload bay. Here we see an astronaut on the end of the Canadarm being moved around the payload bay performing experiments. The most exciting mission was when the Canadarm was used to grab onto the malfunctioning Solar Max satellite, where it was put in the payload bay, repaired, and then sent back off into space. This is up at Spar Aerospace, where you see an actual Canadarm put on what they call the flat floor. And here's Dr. Robert Thirst operating that arm. This gives the astronauts some actual experience using the Canadarm. But it's not in the three-dimensional mode, just two-dimensional, where you can move the Canadarm back and forth along the floor. And you can see that it moves quite smoothly. The arm is just that. It's got a shoulder, an elbow, and a wrist. And at the end, it has what they call a grapple fixture, where you can grab onto satellites. Here, Dr. Roberta Bondar is having a try at the Canadarm with some help from Ken Money as she pretends to grapple a satellite, moving in, and it looks like she's right on. You can see a television camera on top of the Canadarm. A lot of TV cameras are used so that you know exactly where the Canadarm is, its position in space. And when the satellite is let go, the Canadarm moves slowly away, and our pretend satellite is now free in space. That's just a two-dimensional view. If you want to practice using the Canadarm in space, on the ground that is, you have to use the SimFac. It's a mock-up of the inside of the space shuttle itself, close quarters, where you can use, with a computer, an actual Canadarm. That is a simulation. This gentleman here is using it looking at pretend windows where the computer shows you a view like this one from a television camera in the payload bay, and it is as if you are using the actual Canadarm.
The XYZ puts you out a roll that you want it to be at when you release it. So you just type those numbers in here, in position and in attitude.
Okay, so 1, 8, enter.
The arm away, you should start
That's what I
moving
wanna
towards
do.
the tail.
Well, that's what I was trying to figure out which way I was moving, and I was doing this. Moving it towards the tail, or...
You know, you just push it in your left hand and it goes towards the tail. Pull it down as well, because it's obviously way up there.
So you gotta push it out and to the right.
I will push minus 25.
Marc Garneau will use the Canadarm to test several aspects of an experiment to be performed on the next Canadian Space Shuttle mission called the Space Vision System. This vision system will give sharper eyes to the shuttle orbiter and the Canadarm. It will make it easier to approach, capture, and berth large satellites. There are two experiments on this shuttle mission which will be looking at space science. Both of them will be pointed towards our atmosphere. They're called SPEAM and OGLOW. The SPEAM experiment stands for Sun Photometer Earth Atmosphere Measurements. This sun photometer is used by the Environment Service of Canada to measure local atmospheric constituents and to monitor acidic haze. Scientists know sunlight is scattered or obscured by dust, moisture, pollution, and acidic haze, but it is difficult to estimate precisely by how much. To improve the usefulness of the sun photometer's measurements, its absolute accuracy must be established in space so as to compensate for the intervening effects of the Earth's atmosphere. So the objective of this flight is to use the sun photometer to calibrate it and to investigate constituents in the atmosphere which affect the chemistry of the ozone layer. The astronaut will take direct measurements for the calibration of the sun photometer and will point the photometer directly at the sun from a special side hatch window. He will point it at the sun as it sets and rises as the shuttle orbits the Earth. Readings are taken at several wavelengths in the visible and near-infrared region of the spectrum, and the data stored on computer cassette for analysis. Here we see astronauts Garneau, Thirsk, and Maclean in a Grumman Gulfstream 2, which was used to simulate accelerated sunrises and sunsets by diving from 43,000 feet at a rate of 6,000 feet per minute. The other experiment is the O-glow, or measurement of optical emissions glow on and from the shuttle orbiter. Since the third shuttle space mission, crew members have noticed that the orbiter develops a reddish glow when orbiting the Earth. This phenomena could interfere with sensitive optical measurements made from instruments mounted on the orbiter. Canadian scientists planning an experiment in 1988 using a wide-angle Michelson Doppler imaging photometer are concerned about how their measurements could be affected by a similar glow. Here we see astronauts Thirsk and Garneau working with the O-glow, which Garneau will use to photograph the orbiter's tail using a 35mm camera with 12 narrow-band filters and an image intensifier. By determining the intensity of light being emitted by the glow at different wavelengths, clues to the origin of the glow will be uncovered. One of the major mysteries of manned spaceflight that we're up against today is space sickness. The Canadian program is calling this space adaptation syndrome, but really it's just the same as being car sick or air sick. Well, in training, our 6 Canadian astronauts have been undergoing tests on different types of machines to determine how air sick, how space sick they are going to get. Here we see Marc Garneau on a Coriolis accelerator at the Defense and Civil Institute of Environmental Medicine in Toronto. This spinning chair is used to test astronauts' susceptibility to motion sickness and to document the various symptoms.
Looking good, kid.
This is my best pose. That's the right side.
He already made it. Pretty stunning.
That might go. Now.
This is what it would look like if you were on the spinning chair. And let me tell you, if I was on it, I'd want to be blindfolded too. Well, I think I'm making myself sick, so let's move on to the next experiment. Here we see astronaut Tryggvason in what's called an ocular counter rolling chair. In this chair, the astronauts were tilted alternately left and right in 5-degree increments from 0 to 45 degrees. After each tilt, 30 seconds was given to allow the eye to adjust. Each of these counter-rolling angles were measured. This test will aid researchers in predicting who will be susceptible to the space adaptation syndrome. This is a sled at the Defense and Civil Institute of Environmental Medicine in Toronto. Here we see astronaut Money being strapped into the sled chair, where he will report symptoms of motion sickness while being thrust blindfolded back and forth along the track for periods of 10 minutes at a time.
You can see the grain on the wall and the ceiling okay, can you, Mark?
Yes, that's nice focus.
Great. You too, Bob?
Yes.
Great.
Space motion sickness is the most serious short-term health problem encountered during space flight for over 40% of all astronauts. To date, there are no reliable tests to predict who will be affected, little knowledge of how to prevent the disorder once in space, and no fully acceptable means of treating the symptoms once they appear. Here we see astronauts Garneau and Thirsk using magnifying spectacles to provoke motion sickness. These magnifying lenses magnified everything about 30 to 40%. The astronauts performed standardized movements for 1.5 hours, reporting any degree of sickness every 15 minutes.
And Bob, your overall discomfort on the scale of 0 to 20?
I'd say a 1, because I can just begin to feel my stomach.
Okay. Any cold sweating?
No, the rest is 0.
The rest is 0, okay.
Although astronauts have reported that substances taste sweeter and less spicy in space, to date no formal experiments have been carried out on taste sensation. To define whether taste is affected by space travel, this experiment will consist of giving an astronaut a vial of a substance such as vanilla, coffee, or lemon to smell. Once the astronaut identifies the smell, the payload specialist will apply the substance to the crew member's tongue. They in turn will describe the taste. The experiment is designed to find out whether there are applications to astronaut diets in space, and it should help researchers to learn more about how the central nervous system adapts to various situations.
Bitter.
Bitter.
Sour. Sour.
I recently talked to astronaut Steve Maclean about Marc Garneau's upcoming flight on the space shuttle. Okay, Steve, tell me about this upcoming mission in October. What's going to be happening?
Well, there are 5 Canadian experiments, basically. One experiment is the space vision system, where we're going to be obtaining some videotape recording of the ERBS deploy. The ERBS satellite is the Earth Radiation Budget satellite, and they are very interested in knowing what the tip-off rate is for the satellite when it's released from the arm, and so we can give them that information with our system. And we plan to do that on the first day of the flight. The other experiment that we're involved in is the sun photometer. That experiment is a solar instrument that will measure the altitude profile by following the sun. We'll be looking at the constituents that exist in the atmosphere and following what the constituents are as a function of altitude, pollutants, ozone, discrimination, things like that. Third experiment has to do with, it's called ACOMEX, is the acronym. What that involves is putting different types of spacecraft material on the arm and exposing it to the ramjet vector of the spacecraft and finding out what the degradation is after the spacecraft comes back.
Oh, you mean as the spacecraft moves, there's something up there that's going to cause degradation to materials?
Yeah, there's, believe it or not, the oxygen atom concentration is higher than you would think. And when you're in the ramjet direction with the shuttle, these atoms impinge on the material and actually degrade it. Sometimes brown paint goes black or white paint goes brown, that kind of thing. And so we're looking at that problem, trying to find out what the best type of material is according to that situation. What really is happening there is it's a shuttle glow. I'm sure you've heard about that, and that's what's causing this degradation. And we're also looking at that with what we call an O-glow experiment, where we're trying to investigate what the glow is. And so we have a fancy camera up there that has a very high wavelength resolution, and we're going to measure the spectra of that glow and see if we can identify whether it's oxygen atoms or OH radicals. So technically that's what we're involved in that experiment. The one experiment that is life science oriented is the medical experiments, and we have a problem with 40% of astronauts get sick in space, and it's important for the first 3 days or so, and that poses quite a problem. And so there's a whole series of Canadian experiments that will handle and try to isolate why that is.
So we don't know why astronauts get sick?
Well, we're pretty sure that it has something to do with the human vestibular system, but we want to know the physiological process so that we can either find a drug that will prevent it or get some kind of test that will pre-select astronauts, in that we find a system that selects which astronaut is going to get sick, and then he can't go, basically. Right. So it will be a criteria for selection at a later date.
Tell me a bit about the selection process. You must have been pretty excited when you found out in December that you were going to be one of the astronauts. Did you think you were going to be picked?
I didn't know. When we were 19 people, I was pretty impressed with the other 19, and so all I tried to do was give it my best shot. Initially, I expected that there would be 19 clones, 19 guys that walked, talked, and acted the same, but that wasn't the case. You had 19 individuals. So at that point, you didn't know what the criteria was, and you didn't know what they wanted in terms of selection. So all you did was give it your best shot, and I was excited when I got picked. That was quite a thrill.
Do you have any responsibilities with the development of these experiments for the October mission?
Yeah, I'm involved with the sun photometer quite extensively, more as a liaison man or an interfacing man of making that sun photometer astronaut friendly and making sure that the measurements are accurate when they're taken in space. And the other experiment that I'm intimately involved with is the space vision system, and I'm involved in the refinement design of that system so that it has a higher performance level.
And again, that's with the ARM, which is built here in Toronto?
That's right. That's right.
What are you going to be doing during the mission? Are you going to see the launch?
Actually, I will not be in Florida during the launch, but I'll be at Houston. They have a saying, when the bird clears the tower, Houston, the bird is yours. And I will be in Houston at that time because a few hours later we'll be deploying the ERB satellite that Goddard has and giving them the tip-off rates at that time. So I have a support role in that function there. Payload specialist is responsible for a particular experiment. I guess in order to explain that well, you have three divisions at NASA. You have the commander and the pilot who are responsible for flight operations. You have the mission specialist who is responsible for particular aspects of the mission. And then you have payload specialists who are basically scientists involved in an experiment that they're interested in performing and have expertise in that area. And so the Canadian astronauts fall into that category. It is not necessary for us to know how to fly the shuttle. It is our job to do the science in the middeck or in the cargo bay or on the flight deck.
How many hours would Marc Garneau and Rob Thirst have to have gone through to get ready for the flight? Training, that is.
Yeah, I don't know the number of hours total. We've been at it 7 months now. They've had 2 months solid. They will have 2 months solid down at Houston on shuttle-related activities, but the training has basically been around the clock for the last 7 months.
If I was to ask you what the benefits are of sending Canadians in space, could you sum it up for me in a few words?
If we don't get involved in the space program, 20 years from now, we will not be anywhere near the bandwagon. I think space technology is where things are happening. It's where technology is improving the fastest, and I think we should participate as best we can, as we have in the past, but maybe even more now. Otherwise, we'll get behind.
And your chance to go up is when?
I'm hoping that I have a chance in February of 1986, and that is the second flight, and I'm crossing my fingers for that date.
You must be. It must have really affected you since you became an astronaut just 8 short months ago. Are you tired of these interviews by now?
No. Actually, when I do public relations, it's a break for me because we're working so hard. Like today, I was able to get a couple of rides at the X, which I haven't done for a long time, and it actually is something that is interesting to do. Gives you a break from the normal routine.
We appreciate you talking to us on Astronomy Toronto.
Okay, thank you, Randy.
Thanks, Steve. Within the next 2 years, 3 Canadian astronauts will travel in space. This is an exciting time for all Canadians, and we've been happy to bring it to you on Astronomy Toronto.